Hello, thank you once more for stopping by my channel and taking time to watch this video. Please do kindly like and subscribe to my channel for more videos on data analysis. So in this video, I will be dealing or talking to time series data analysis basically. So I will try to talk a little about what time series data analysis mean, what are some of the idioms. I'll talk to the step-by-step process on how to analyze and of course interpret your data, your time series data. I'll talk to how to create graphs, how to do a descriptive statistics, analyze unit root test, run an ARDL model, and the basis for which you make a choice of model. I'll be using both Eviews and Excel in this analysis, using Eviews 9 and of course Microsoft Excel. So in Eviews, I'll just create a new worksheet. Now the date, that depends on where I want to start and end my data. This data have been downloaded from various sources, from CBN database, World Bank database as well, and pulled together. So I will make use of 1990 to say 2020 or 2021. So of course the choice of years depends largely on you, but the more the year, the better it is, so that you have enough variation. So in my Eviews here, so my start date will be 1990 and the end date will be 2020. So let's call this work file practice. Then you click OK. So of course the frequency is an annual data. It's not quarterly, it is annual data. Okay. That's annual. Then it's dated, of course, regular frequency. Okay. Okay, so that means we have 31 observations. So let me come back to my Excel now and see the data. Okay, so this is the raw data. So I can easily create a new sheet. This is education, human health. This is Nigerian data now. Human health and social services, per capita income, foreign direct investment. So let me create a new sheet so that I can use it for practice. So all you need to do is hold Ctrl Shift and hold the left click down. See where my cursor is. Just click down. So I hold the left click button down and move. So I'll just duplicate that sheet. So that sheet has been duplicated. So let me take this out. I'll show you how I got this. Then we want to use 1990. So I'm just trying to clean up. Delete this part. Then okay. So, so yeah, so the data set has been cleaned. So now we have for the years 1919 and up to 2020. So this data set is at level as raw as it is. No, of course, this has been converted. This was collected in billions. This was also in billions of naira. Per capita is also in naira. FDI also will convert this to billions shortly. So time series data analysis, just by way of introduction, is a kind of data analysis where you use most often time series data secondary to the user. Of course, you can have a time series that is primary when you have a scheduled time to go and collect the same data uh, on the same variables. But in this case, this data is secondary to us as a user, and it is collected over a period of time, say annually, weekly, quarterly, biannually, for a long number of times. So for this case, it's annual data from 1990 to 2020, and often they are macroeconomic data. So before you make meaningful analysis or inference from a time series data, it is expected that the data is normally distributed. Normally distributed meaning having a mean of 0 and a constant variance. So hence there is need to, of course, do what they call the unit truth test. That's a test of stationarity. I will show you all that as I progress. Okay, let me name these sheets practice so that it will be easy to make reference to practice. All you just need to do is right click. Once you right click, you see the option rename, so you rename and enter. So once you have your data, doing analysis with your data, you can either use the data as it were or you log the data. Now the difference between using it as it is and logging the data is when you log, there's tendency that the coefficient will be reduced. Also, when you log, it becomes in cross-sectional data is now called double log or double as it were. So the essence is one, you reduce the coefficients and it is assumed to have better relationship. So to do that, I can easily just log here. So I just say to log, I can just copy this education. Let me call this ln edu. Let this be ln health. So I'm just trying to log, so I have it here, nl bci ln fdi. Okay, but before logging, I want to bring my FDI into billions as well. So I can, to bring this into billions, let me say FDI in billions. So I will just divide the current answer by 1 billion, divided by the current figure by 1 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. Enter. So all this equal sign. All command in Excel. If you want to put a formula, I want to give a command, it stands with equal. So I right click, I just click on the cell of interest, then put that 300. So Excel, of course, most times relative terms. So I just double click. Now, because this video is about Eviews, I'm not going to pay attention to the commands I'm using here in Excel. So having done that, I will just say equal. From here now, I want to log this equal ln So that's natural log. Double click, I put the number of interest, the cell of interest, cell reference, close the bracket, enter. So since I've done that, I can just drag to PCI and stop. Then because of the gap in between, okay, of course, I just drag to FDI. So double click. It's simple. I just drag, make wait till. Look at it. I just drag, wait till I have this thick dark cross, drag to my far right that covers all the cell of interest. Then come to the far right again, double click, it will produce, automatically generate the rest, because Excel thinks in relative terms. That's what the software is. So now the software is set for data analysis. But the first analysis we want to do is to see the graph. We want to see what the graph of this what the trend looks like, so that it will help us decide on the kind of unit root test we'll be doing. So let me pick the raw data to do the graph. So I copy, I'll highlight these columns of interest, and I'll copy, come to Excel, to my Eviews, right click and paste. So click on next, then it gives you a dialog box where you put the start year. So the start year is 1990. It automatically populates here. Then you click on finish. So I just copied FDI down there. Okay. So let me start with education. The first thing I'll do is to generate graphs and look at what the trend looks like. Then I can just take a sheet of paper and note it down. So if I double click on I'm interested in education, take my cursor there, double click, it gives me the spreadsheet, click on view. I want to see the graph, click on graph. I want to see the linear graph, just the linear graph using the raw data. I don't want to do any further analysis, just the raw data as it is. Then I click OK. So I've seen this. So this is the trend of education expenditure from 1990 to 2020. So you can see that it exhibits an upward trend till it gets to the peak here, and of course it's nosediving a little. This is the year 2019. That's when it started coming down. But along the line from 1990 to 1999. 1999, it was moving upward slowly before, of course, it became rapid from 2020. But of course, we can always have an explanation for this. In the Nigerian context, is when we switch from military to civilian rule again. So you can always find economic implication of the course of science. So education is trending upward. So this is trending basically. Okay, close that. FDI, I want to see what FDI looks like. The graph, the same process I'm repeating. The graph, then you check. Whoa. Okay, I'm trying to be time conscious. I don't want the video to be too long. So FDI has not a constant flow. You see it's moving zigzag in a zigzag manner. So it's almost like intercept. I'll show you where that comes in. Where education was trending, but this went up and is also coming down. So this has been how foreign direct investment is in Nigeria from 1990 to 2020. Does not have it peaked at the year 2011, and started descending down to 2018 before trying to get an upward trend for indirect investment. So the FDI more like intercept. Of course, you can add this to your write-up to give it flesh, and of course show what the variable looks like. It's descriptive in nature. Then this is for human health and social investment. All you need to just double click on the variable of interest to come out in a spreadsheet. Then graphs, basic line graph, then say okay, human health and social services investment in this life has been trending upward. It's trending upward. It has increased and it's still increasing up to 2020. Alright. And per capita income, the same thing comes to the variable, double click and click on view graph. Okay, per capita income also picked up. It's like education now. It picked up in the year 2020 and moved sharply up till it peaked at 2014. Then of course you can say that it's still trying to rebound. It came down and is trying to exhibit a zigzag movement. So this is PCI, its trend, and of course there's intercept. So having done that, this is the first process in your data analysis or time series analysis. The next thing you want to see is to check the descriptive of it, to see the summary statistics of what these variables look like. So I want to select all the variables and see how the mean and the median, just see the summary statistics of all. So I hold down my control button and select all the variables. Right click, I'll open as a group, then just drag this up. So what I want to view the descriptive of the common samples. So from this, you can easily see, okay, the mean of education, so the mean expenditure on education in the year under review is around 856 billion. The mean foreign direct investment is around 308 billion. Mean expenditure on human health and social services 298 billion. Then the average per capita income for the year under review is 3,565. Alright. So we see the median, maximum is here, minimum. The skewness tries to tell you if the data set is positive skewed or that's right skewed or left skewed, positive or negative. And the kurtosis help us to talk to the degree of the kurtosis and the skewness together. When you combine, gives us an idea of whether it is normally distributed or not. Also the Jacob test. Alright. The kurtosis is expected to be above 3, but sometimes it's below 3. So if it's below 3, it's a statistic. If it's above 3, it's also a statistic. So U has different implications. Alright, so when it's above 3, it means that I think it has a more let's say extreme value from normal distribution, and when it's below 3, it has less extreme value, I think, of normal distribution. Alright, there's a name for it. Alright, so but together they talk to the normality of your data. So but from what I am seeing right now, these variables are not normally distributed. the Jacobara test, I think they are not, most are not significant, so they are not normally distributed. Most time series data in a raw form does not come being normally distributed. So this is just an idea. So, but to further check, we have to give the unitary trace. So descriptive statistics largely just tell you what it may look like or what it does look like, but to make you can't make inference from descriptive statistics. You make inference from inferential statistics. So, but descriptive statistics lay like a foundation, show you what the variable is most likely going to look like. Then you go further to inferential statistics to get the real uh, uh, position of the data. So, the next step you undergo in your time series data analysis, you run your unitary test. Okay. So I can close this. Of course, all analysis I've been doing for the purpose, if you are going to use it for your work, you'll be copying. To copy is easy. It's that you can decide to save it, but of course you can just copy it so that because you have so that you don't have several. Copy it and paste it in Word. If I Control A now, that's select all. I'll right click, copy. I'll just copy as text and copy as displayed. Okay. So you just go to Word. It's easy as that. This is Word. Okay, this is another analysis. So you just click. I just pasted. So this is how you can of course copy every other table and have it. So that's that. Okay. So back to our analysis now. So we want to check the unitary test. I can delete this group. So let me pick education for instance. So I can double click again. So remember we looked at the graph. So this is exhibiting trend and there's a little, this is trend. So unitary test, the same place view, but now I want to view the unitary test. So you unitary test, you view it at level, at first difference, at second difference. The other type, there is Phillips Ferroni, there is Dickey-Fuller, another type, but what is commonly used is Phillips Ferroni and augmented Dickey-Fuller. So I'll be using augmented Dickey-Fuller for this. So given the way the variable is, this is having trend and intercept. This trend and intercept. So it's not a straight line upward, right? So I will leave this at trend and intercept. So okay. Wow. So of course this is stationary at level. But you can of course and how did I know this? Okay, let me talk to that briefly. The T statistics, the augmented Dickey-Fuller T statistics must be higher than at least one of the test critical values at 5, at 1, 5 or 10% level. It must be higher than at least 1. In this case, it's higher than all, so this is significant at 1%. So education can be said to be stationary at level. You can write that down. Guys, it's integrated at order 1 over 0. You can copy this down too if you want to. Just Control A, copy as displayed and keep. Okay, but there's no need to copy. So you now just check the order now just for formality, just to populate your table if you are going to be presenting your result. It's also stationary at first difference. Let me see, at second difference. No, it's not stationary at second difference, but stationary at level and at first difference. So you can copy that result and just keep. So for the FDI, click. this is more like this is like intercept. It's rotating around 0 the way it is. It goes up, come down, goes up, come down. So the trend is not far from 0. It's rotating around 0. So this is intercept. So I'll come here from view, unit truth test. I'll put this at intercept. Then let's check at level. Okay, now it is not stationary at level. Remember, I said this must be at least greater than one of the critical values. So I can copy this and keep. Let me check at first difference. Wow, so it becomes, so this is the foreign direct investment, FDI, integrated at order 1 over 1. It's integrated at first difference. So the critical value is higher than the other critical value. So you can also just check for second difference. Okay, it's also integrated at second difference, but we are interested at the first time, or at the first place where it became stationary. So let's look at health. The health is largely trending. So we can also use trend and intercept here. So come unit truth test. Put it at trend and intercept. Let's check at level. It's not stationary at level based on the t value. Let's check at first difference. Okay. This is 10%. 10%, but no, we are looking for is the above 10%. So let's check it at second difference. Wow. So it became stationary at second. So human, so it became stationary at second difference, order 1 over 2. Alright. So that's okay. That's that. And let's check the per capita income. This is trend and intercept. So come here, unit truth test, trend and intercept. At level, it's not stationary at first difference. It's not stationary at level and at first difference. And it became stationary okay at second difference. So PCI is also order 1 over 2. Alright, so having done this, you have seen that okay, before this variable becomes normally distributed for education, is normally distributed as it is, since it's stationary at level. For foreign direct investment, is at first difference. For human health and social investments, at second difference. While for per capita income is also at second difference. So, but for the purpose of this analysis, we want to just do an ARDL model, a bond test, and a test of heteroscedasticity. So it means that the axiom of ARDL model is that the variables must be stationary at order 1 over 0 and order 1. So it means you may not be able to use human investment of human health and social service and per capita income for ARDL analysis. Rather, we can use a vector error correction model for that analysis. So let's check now an ARDL model to see the impact foreign direct investment on education in Nigeria for the period of 1990 to 2020. So, education, independent variable, I hold down the control button, FDI, the independent variable, I right click. Now at this point, I can decide to go and use the logged version of the variable. But let's run the analysis. If the coefficients are not too high, then we are fine, we are good to go. But if the coefficients is too high, we come and use this. That's just the purpose why I'm logging it for this analysis. There are other reasons again, the way it affects. Another difference is when you don't log, which is a linear form, it means when you're interpreting unit increase will lead to unit increase. But if you log, percentage increase will lead to percentage increase because you have differentiated, right? So that's just a little difference there. So again, education, because it's my dependent variable, I click on it first, hold down the control, FDI. So I want to open as equation. So you can see the equation, education, dependent variable, FDI, independent variable, then of course constant. I will try to add a control variable. I'll run this analysis this way, then subsequently I'll run it again, adding a control variable so that we can see how other variables, because of course foreign direct investment is not the only variable that has impact on education. So we can of course add other variables. These variables will now stand as control variables for the analysis. You can add other variables just for control. If you don't want to log, another way is you can reduce your coefficient is to add control variables. Although it depends largely on the objective of your analysis. So I have other control variables I can add other control variables. Okay, I'm trying to get some control variables. I think I downloaded some data earlier. I can add. Okay. All right. So the next thing to do now is to okay. All right. So okay. Nice. I've gotten my data now. I'll open it up and add as control variable. All right. I was just trying to copy it. Okay. So you will now select. Just click here. The method is not least square. So okay. New data I got. Okay. This is the World Bank data I downloaded. This is inflation. So Nigerian inflation. I can add that as control variable. Let me just come here. So I'm picking from 1990. So this even the other data, this is the way I got it. 1990. Copy. just come down to where the data set is. So let me give it space. Right click and paste transpose. So this is inflation. So inflation, and copy now. Yeah, I just want to add this to the list of variables. So copy inflation 2020. Control C. Just come to Eviews and close this one now and paste. So the same process, right click, starting from 1990 and finish. Okay, so we have inflation here. Alright. Okay, so let's quickly go back to analysis. So foreign direct education, I hold down the control key, open as equation. Then come down, I want an ARDL model. So now on this part, it depends on how this dialog box depends on the model you specified in your write-up. For me, I don't want it to be automatic selection. I want it fixed, and I want to allow for one lag in the dependent variable, and the independent variable I want to see up to, this is 2020, so I want to see what it looks like in 2019, 2018. That's 2 years, so I'll lag it twice. That's what I'm interested in. So I'll say okay. Alright. Yeah. So these are the statistics. This is the ARDL. This is the education we lag. So FDI in 2020, it was not significant based on the t value. Most times we say the impact of economic policies is not felt in the same year, it's felt in the subsequent year. So in any case, 2020 is nothing. 2019 is nothing. So in 20, this is FDI minus 1, this is 2019, significant at 10%. This is 2018, significant at 1%. So the ASIOM, or the assumption, better still, not ASIOM, the assumption is that what is felt in 2019 is as a result of the policies in 2018, and what is felt in 2018 is also as a result of the policies in 2017. Now, this is not a hard and fast rule, it's just an assumption. So 2020, it means, okay, the policies in 2019 probably is not yet felt in 2020. These are just ASIOM. We can play around by making economic assertions and assumptions, and of course trying to liken what your result may be, also largely depending on the happening in that period. But this is what the statistics is for 2020, 2019, and 2018. So at the point of interpretation, you can decide how to. But now we're having a R square that is so large, it's 99%. So this is what we're trying to avoid, because there are other things that affect educational investment, not only foreign direct investment. So this R square most likely is not so. It's not really correct, and the worsening statistics is a little low. We expect it to be between 1.98 and 2.02. You know, that is acceptable. Best range is acceptable. The F statistics is okay, but it's just way too high. So let's try this analysis again by adding, of course, delete the equation, by adding a control variable. So I'll say this again. Now my first control variable now is inflation. Just to reduce, see if it has effect on scaling down the coefficient. ARDL, because I'm also taking fix. 1, 2. Okay. The effect is not much. The F statistics has been scaled down. The Rho scaling is a little close to the acceptable range. The R statistics just reduced a little. Okay. So next thing we can do is, okay, let's use the logged version of this to see if it has effect. Let's come back here. So I can also log this, log ln inflation, the same process, equal to ln log. Let's see if this will help. So I can copy this, to see, come to paste from the year 20, no, year 1990. Alright, so that started 1990. Issues to 2020. I think I need to recopy this. I want it to carry any. Let's copy it again. Alright, copy, paste. Next, again, 1990. It's better. Finish. So let me copy the log of education and FDI and see if it can help us reduce. I don't know if it will reduce the R square. Largely this is for the coefficient, but let's just try. FDI largely this is the logging is for the coefficient, not R square. Okay. Next. 90. Come back. Education. Education. Okay, so let me attempt that again. So education is a dependent variable. Education, hold down control, this, education. I want it to be fixed. Just want one like here. I just want to see 2 years. Okay. Okay, I still have large R square. So what is happening here? The F statistics have reduced, the long-lasting statistics high. So what is the major problem? Why we're having this high R square? Have we differenced? Let's go and difference. So this is how you keep working with your data. The approach is right, but the statistics you are seeing, you want it to be what is presentable. Right. So delete this. So remember, we said, let me check the unit root test. A graph for inflation. using the raw data. Inflation. Forgot to check this. Quickly check the graph. Okay. Oh. So this is intercept inflation. So let me check the image test. At level, intercept, stationary at first difference, at second difference, at first difference, at level no. But yeah, so inflation, stationary at first difference. One, that's other one. So what you can quickly do again going forward, that's the step that I've not done, is to difference your data set. So I say difference, can do it manually. Difference FDI. So I want to difference FDI means we are going to minus current year from the previous year, the statistics of the current year. So we can say that's to detrend it now. I can say this take this minus 20 20 19 1991 minus 1990. Difference it. Difference. Copy and paste. Difference FDI. Now, when you check the unit root test of this, it will just be normally distributed automatically. It will now be around 1990. So you can check this. Look at the graph. So this is what we are actually expecting. This is a normally distributed time series data. That is rotating around 0, mean of 0 and a constant variance. This is what a normally distributed time series data. We have detrend it. So the next, inflation, right? Inflation is also stationary at first difference. So let me difference it. So inflation, okay, I can do that here. Difference inflation, I'll say equal to this 1991 minus 1990. So let me run that. Copy this. So I've also difference because the shader becomes stationary at first difference. So that's what that actually means. Next, 1990. So look at the inflation too now. Discover that the data in graph. Alright, so it becomes This is 0. So it revolves around 0. So now I've detrended the data. So let's run that ARDL model again. Education, pull down constant. My main variable of interest is FDI. The control is inflation. Copy. I just highlight, open as an equation. ARDL model. Mount it fixed. Wow. So we have done all the possible way to do the analysis. The R square is high. So these are different ways you can do your analysis. So with this now, it shows that, okay, say that the data has problem of multicollinearity or otherwise. So these are the approach. The approach is right. So it therefore means that largely, after exploring these three options, the R square is still remaining at 99. Say that we add more control variables. But what we have now therefore means that largely foreign direct investment has a large impact on the education in Nigeria. That's what it means for the period of 1990 to this period. That means we've attracted a lot of foreign direct investment. So let's go back to the first analysis we ran. We can come back to education, FDI, education rate. So the same approach. This fixed. Let me allow for 4 lakhs and see. So this is what we have now. Allow for 4 lakhs. Alright. So the double Western statistics is better now. Now all we have been trying to do is to explore every possible way to do the analysis. Then we'll now pick the best result. The approach is constant, and every approach I've done is statistically okay. That is all the manipulations, the processes, trying to see how to get it right. Okay, so what you now do as a data analyst, after exploring all avenues, you don't just do the analysis once and quit. You try to explore all possible avenues. The core is that the unitary stress is stationary at order 0, 1 over 0, and order 1 over 1. That is the basis why you can run an ARDL model. So once that is established, the other processes are also right. You try to explore the possible options. So when you have exhausted this, then you now pick the best results you have. So after doing this, the next thing you want to do is to run a bond test analysis. So if I'm to, okay, let me run for just 2 and interpret the result. So you see, ARDL model, let me run for just 2 years. Let me just, for just 2 lags, then I'll interpret the result. Fixed. Okay. So for this, we can say that now FDI is stationary at 10%. Was significant at 10% in 2019. It shows that it was negative actually and stationary. So it shows that a unit increase in foreign direct investment will lead to about 2.9. Okay, there's 0.029 thereabout unit decrease in investment in foreign direct investment in education. So increase in FDI for 2019 did not result to increase in investment in education. That's what it meant. But in 2018, we're saying that it's positive and strongly significant at 1%. So an increase in FDI in 2018 led to increase in education investment based on what we can see. You can either for inflation, okay, inflation is never statistically significant for the years. So again, another thing you want to note is that variable that you are adding as your control variable it's advisable that it is statistically significant. Probably that's why it's not really reducing the R square because it's not significant. So we cannot actually add other variables, but I don't want this video to be too long. The core of the analysis is FDI and education and investment. Every other addition is just to find a way that we have a good result that we can interpret. So this is short-term model. So we can check for the long-term. The long-term, we want to check for the long-term estimate. You come to view coefficient diagnostics. Let's check for the bound test. Now the axiom for the bound test is that the value, the F statistics of the bound test, should be greater than the critical value at 1, 2.55 and 10% respectively. Once the value is higher, that means there is a long-term relationship. So what we have here now is showing that yes, FDI do have a long-term relationship with education. So you can, once there's a long-term relationship, you can ignore the short-term estimate and just comes directly to interpret your long-term. And of course, we see that we have a beta R square 65. Yeah, this is beta R square, beta R F statistics, and beta level 1 statistics. So you can interpret this directly. And FDI is significant at 1% for 2019, but okay, inflation is not significant. FDI is significant. So this is showing that in the long run, of course, we're seeing that this, of course, although it's showing the statistics for the long run, and the R square shows that the level, the 60%, the R square is 0.65, so it's showing that 65% of the variation in education is as a result of FDI. That is 65% variation in investment in education is as a result of the foreign direct investment. Also, that is showing the F statistics, which is significant at 1%, shows that the model was well specified. I wish I can run another analysis to show when this is not significant. So if you run, you can also see a case where this F statistics is below, it's not significant. So once it's below the critical values, say for instance, this F statistics is now say 2. So it means it is not significant and there is no long run relationship. So you will not interpret this. You just ignore it. So you go back to the first statistics and interpret. So we can also now view the heteroscedasticity. So I prepare this Regression test. Okay. This is expected not to be significant because it's stated that there is no heteroscedasticity. That's the null hypothesis. So this is significant at 5% based on the value of the F statistics. So we accept the null hypothesis. So this is either you accept or you reject the null hypothesis. So based on, now this is relative to how you have stated your hypothesis. You either accept or you reject. Now in any case where there is problem of heteroscedasticity, you may have to either discard that analysis or treat the problem first. Now we can't do that in this model. We have to do that. We can't do that in this video. The video is already long, so I'm deleting the equation now. So this I've been able to show you the step and various analysis. So just lastly, before I stop the video, I'll just do a Granger Causality Test between education and foreign direct investment. Again, now in this case, you open as a group, then you view causality test. 2 lags. Now there's a way to, in one of my videos I showed how to determine the lags to use. So you can watch that video. So this is time series data. 2 lags is okay. So just say okay. So the first hypothesis is FDI does not Granger cause education investment. This is significant. So they accept or reject the null hypothesis in this case. So FDI does not Granger cause education and vice versa. So education does not. So you test based on the, even for the heteroscedasticity test, and it's based on the hypothesis you have specified. Are you testing at 5%, 10%, or 1%? Most often you test at 5%. So based on the hypothesis you specify, whether you accept or you reject your null hypothesis. So now, thank you. I think I can stop the video here. I've been able to, just a quick recap, I've been able to run you through time series analysis using an ARDL approach. Now, the result is because this data, okay, we got this, they are real data, we got data, and it's just for the purpose of practice. It's just for the purpose of practice. So if you are going to use it for maybe a project or a research work, you may need to pay more detail and more attention to your data cleaning process before you move it for analysis. Thank you once more for watching the video. Kindly like and subscribe to my channel for other videos.